Lesson 4.1 Circles. Our essential question is, what is the standard form for the equation of a circle, and what does the standard form tell you about that circle? This is the first lesson in a unit on quadratic relations, because if you look at the graph of a circle, it's clearly not a function, but it is a quadratic relation. I'm going to leave you the derivation of the equation of a circle. I'm going to leave that for your geometry teacher next year, and I'm simply going to present to you the equation. So if you'll turn to the next page, page 160, and in the middle of that page you will find the standard form for the equation of a circle, which is x minus h quantity squared plus y minus k quantity squared equals r squared. Now really the basic equation for a circle is simply x squared plus y squared equals the radius squared. And that is with a circle centered right at the origin. And r is your radius of the circle. So that would be the distance from, let's say, the origin out to any point on that circle. So your radius, that is the same distance. And notice the equation is r squared. So if you wanted to find the actual radius, you'd have to take whatever number was there and take the square root of it. Now when we transform this circle, we move it left or right, up and down, it follows our same transformation where we have x minus h quantity squared plus y minus k quantity squared equals r squared. And this is where our, let me get my highlighter, h and k is the origin, or the center of your circle. So h comma k, okay, is the center. So if you know the center point of your circle, right here, and you know the radius, then you just substitute in for h, substitute in for k, substitute in for r, and you have your equation for the circle. So I've made up my own two questions. Feel free to just copy these down on your book somewhere where you have some white space. So what if you're given the center of a circle is 1 comma negative 4 and the radius is 3, and you are asked to write the equation? Well, we can do that because we know that the formula is x minus, of course this is h and this is k, x minus 1 quantity squared plus y minus k, which is a negative 4 quantity squared, equals the radius squared. So let me simplify that to y plus 4 quantity squared equals 9. And there is our equation for a circle. Now I can reverse that question and ask you, what is the center and the radius of the circle given the equation? So we're simply going to look at these numbers right here. And we know that the formula, let me change colors, is x minus h quantity squared plus y minus k quantity squared equals r squared. Right. So that means h is equal to negative 2, k is equal to 6, and r is equal to the square root of 25. So our center would be negative 2 comma 6, and our radius would be equal to 5. In this case, we're going to take the positive root because we're talking about a linear measurement and we do not want a negative 5 radius. Looking at page 161 in the middle of the page, if you were to expand the standard form of an equation for a circle, so if we were to multiply this all out, you get a second degree equation in which you have an x squared, you would have a y squared, you'd have some number that we're just going to call c times x, you'd have another number d as a coefficient of y, and then you'd have e, which would just be a constant, equals 0. Now sometimes the equations arrive in this expanded form. And it's kind of difficult to see any of the information when it's in this expanded form, right? We can't really see the radius, and we can't see the center of the circle. And if we want to graph it, those are the two pieces of information that are the most helpful. We can plot the center of the circle, and if we know the length of the radius, then that makes it much easier than to plot some points and connect them for a circle. So what we have to do is take this equation, and we have to put it in the standard form for a circle. So I'm going to walk you through this example 2a. So you can kind of follow along just by watching. You don't have to copy anything down. So here's this expanded equation for a circle. All right, so the first thing you want to do is group the x's. So we're going to group this x squared and this minus 10x. And then we're going to group the y's. So we're going to group the y squared and the 6y. We're going to put the constant on the other side. So that will make that a negative 30. And then what we have to do is complete the square for the x's and for the y's. So we're going to take that negative 10, divide it by 2, which is negative 5, square it, and get 25. The same with the y terms. Take 6, divide it by 2, square it, you get 9. Now we just added 25 and 9 to the left side, so we also have to add it to the right side, 25 plus 9. We have created a perfect square here, so we can factor it as x minus 5 quantity squared. We have created a perfect square here. We can factor it, and we get y plus 3 quantity squared. On the right side, just add those numbers together and you get 4. So that tells us that the center of our circle is at 5, negative 3, and the radius is the square root of 4, which is 2. So in that case, I plot my 5, negative 3. That's the center of it. My radius is 2 units. So I'm going to go to the right 2 units, put a point, go to the left, put a point, go, I guess, north, put a point, go down south 2 units and put a point, and then you can connect them smoothly for a circle. So let's try another one. If you'll turn the page to page 62, and we're actually going to jump down here to the bottom, your turn, number 5, and we're going to graph this circle after writing the equation in standard form. So first start by grouping all the x's and the y's, and I've kind of highlighted them here. So I'm going to write x squared plus 4x. Now, plus, and I'm going to leave that blank empty because I know I'm going to complete the square, plus, then the y squared plus 6y plus, and again, I'm going to leave a blank there for a number, equals, and this 4, I want to bring to the other side, so that's going to become a negative 4. All right, now I need to complete the square. So 4x divided by 2, quantity squared, is 4. 6 divided by 2 is 3, and 3 squared is 9. Now I just added a 4 and a 9 to the left side, so I have to add a 4 and a 9 to the right side to keep that equation balanced. Let's factor. We get x plus 2 quantity squared and y plus 3 quantity squared equals 9. All right, now it's in standard form, which is so much more helpful. Our center is at negative 2, negative 3, and our radius is the square root of 9, which is 3. So let's move over to our graph where we can graph that. All right, let's plot our center point first. -2, -3. So there's my center. Our radius is 3, so go 3 units to the right. 1, 2, 3. Go to the left. 1, 2, 3. Go up. 1, 2, 3. And down 3. 1, 2, 3. And I'm going to change colors just so you can see the circle. And then carefully draw your circle. And there you go. Tomorrow in class, we'll discuss these problems where the x squared and the y squared have coefficients. We're still going to do the same thing. We're going to complete the square, but we do need to deal with those coefficients, and we'll cover that in class tomorrow.